Hello, everybody. I got sunshine after a rainy day, or 3, or 4. Okay, welcome everyone to See and Learn 2023 for our group from Canada, Floatin' Flag. Woo! Thank you for being flexible and patient and coming. It's our 20th anniversary. And thank you everybody for coming and our experts who got here. A special thanks to Sea Saba Dive Center who got everybody here. Round of applause. So we've got a little double header tonight, so we're going to get started. Everybody's ready?
Bring it.
Sorry you didn't get the video music, but we're ready. So hello to our home audience. Thank you, and sorry for the disruption of the schedule. But there were some things going on Saba, but now we're pretty much on track. So here we go. Carib Trans is who makes our live streaming possible. So a round of applause for Carib Trans. If you don't know what they are a freight forwarding company. So when you get Amazon in a day or two, we get Amazon in 10 days. Not bad. So thanks to Carib Trans. Okay, Spyglass Villa is a beautiful, beautiful home on Saba. Spyglass Villa is a beautiful home on Saba, and they are the sponsors of our speaker this evening. So a round of applause for Spyglass. And it really does have a 360-degree beautiful Spyglass view. Prince Bernhard Culture Funds and Public Entity Saba make our program possible. They have been supporting us since the beginning, so thank you very much, and a round of applause. But as you can see, and when you get your t-shirt, for all of you who participated today, on the back of it is a QR code. The QR code takes you to all of our sponsors. And there's more than 50 of them. When we started off 20 years ago, there was 4 or 5. Now we're at over 50. So check out those logos and do a big thank you for anybody you see. And those sponsors include some people who are here tonight and some people who aren't. So for the group staying at the Cottage Club, Mark from the Cottage Club is a fantastic supporter of See and Learn. We also have Joshua in the audience, our parrotfish expert. He's staying at Juliana's Hotel, which has been a 20-year sponsor of our event. Our speaker tonight is at Spyglass, as we said. And we have Larry and Sherry in the crowd, who are sponsors of Flamboyant Cottage, and they are very good supporters. And we have Andres and Ava. El Mamo Cottages is one of our original sponsors for 20 years and great supporters of our event and many events throughout the year. I think I covered that for now. Okay, so get your phone out and take a picture of that QR code, because another cool thing of our 20th anniversary is that a platform, kind of an app platform, has been launched in support of See and Learn and for our 20th anniversary, and that's thanks to California Academy of Sciences, who's been supporting us for a long time. This new platform takes you, they did a soft launch the other night, and you can check out the many nonprofit organizations on Saba that are about cultural heritage and nature. So our Heritage Center, the museum, different places. But it also tells you about the trails and the dive sites and See and Learn's Adopt-A-Boxes. So for those of you who can't handle the trails, you can do a walking tour going box to box on the island. So that's worth a look. Thank you very much. Raffle prizes. Did you hear we have raffle tickets? I think we did a good job of that before we started, so we won't take too much time from the home audience, but have a look. More than $10,000 worth of prizes for $5. Like, your chances of winning one of 20 prizes is pretty darn good, and we're going to do the drawing on Friday. Upcoming events. Emily changed the slide, it looks like. Yay. Yeah. So, as you might guess, we spent the morning rescheduling everything because of the weather and such, but we think we have it all down. So, tomorrow night, we will do a presentation at Queens with Ian. Dr. Ian McGaw is a crustacean expert, so that promises to be super interesting. We provide free transport to the hotel, beautiful place, special dinner at a great price, so join us for that, either in person or online. Tomorrow afternoon, we have a dive with tonight's speaker, and she's going to convince you why you want to make sure you can be on that dive. And now there is space due to other circumstances, so tell us if you want to sign up for that. And then Thursday night, our land crab expert is going to do a night hike. Really cool. But don't worry, it's not a super aggressive hike. It's a walk in a forested area where he's going to tell you tomorrow night how cool that's going to be and what we're going to find. It's not up Mount Scenery. So yeah, sign up at the tent, text us, whatever works. So if you participate in any field projects, so today's dive qualifies as a field project, you get a cool t-shirt. So Ellen is one of our great supporters. Stand up, show them the front and the back of the t-shirt. Come on. And Hendrik, okay. Don't knock over your drink. So these are the cool t-shirts. We also have ladies' tanks, so you can get a tank top or a t-shirt. They are totally sustainable, made from recycled plastics, but super soft, comfortable, great to wear. All right, and now for our 20th anniversary, raise your glass if you got a cloud top. Woo! Lots of it sold tonight. So this is a special beer that was made just for us and for Saba, being inspired by Saba Spice. So drink and enjoy and contact us online if you want to support that. Okay, so now we're going to have a little mini presentation, something else that we invited these folks to explain this to you tonight because it's water, but what does that have to do? Well, what they're going to explain to you is how it's also really reduced the amount of plastics on Sabas. So this is a really sustainable thing. I believe it was greatly supported by our Dutch government, but we're going to let them tell you all about it. So I'm going to introduce you to Oscar. So a round of applause for Oscar.
Hello, good evening. Thank you for having us. First of all, I want to thank Lynn for inviting us to be a part of this wonderful event. See and Learn, as you heard, is here for 20 years and many more years to come. And as she indicated, as you can see, this is a very common depiction of what we see in the Caribbean and basically anywhere around the world where you have a shoreline. So the thing is, it's not a pretty sight. So what can we do? What's our part in trying to reduce this or getting rid of it altogether? So a couple years back, about 2016, the government collaborated with the Dutch government in finding a solution to providing safe and healthy, reliable drinking water to our local population. As you know, we don't have a piping system on the island. Everyone has a separate rain reservoir called a cistern, and we're all heavily dependent on rainwater. As you know, just like everywhere else in the world, we're affected with droughts like everyone else. So we came up with a different solution, reverse osmosis, desalinating the seawater. Now, as you can see, we got lots of seawater around us, so never ending. But what do we do with the plastics? As I said, we live on an island. Everything we have is imported. So that also includes water. So we came up with a solution. We provide drinking water by bottles, 3-gallon and 5-gallon, as you see displayed at the front. So it's still a problem. It's a plastic. We try to encourage, just like Sea Saber and See and Learn is trying to educate the folks. Beware of what sort of plastics you use and are they recyclable, to avoid things like this. So, like Sabre, we try to encourage, reduce the carbon footprint as much as possible. So, like I said, we came up with a solution to provide safe drinking water in bottle format. So like I mentioned, we have plastic pollution, just like everyone else, but we try to limit it by providing a whole different product. Doesn't mean that we don't import water from anywhere else, we still do, but it's a lot less, causing lots less of what you see here. As you know, wildlife is the main problem that deals with our refuse, so we try hard to encourage people not to make that mistake. Like I mentioned, we use our bottles in a reusable system. As you can see, Sabre doesn't have water that's by law qualified as drinking water, because what we catch in a cistern is what we call by Dutch law potable water. It doesn't make it drinkable. The thing is, microbes. We can filter sediment, but we can't really filter microbes out of our water. So to safeguard your drinking water, you would be required to boil it, get rid of the microbes. Back years ago, we would maintain our cisterns, but that's not the point anymore. Everyone's gotten complacent and no one cleans, hardly repairs. So you have a buildup of stuff that's not good for the system. So we encourage drink bottled water. As you can see, it's locally made, it's safe, it's healthy, and it's affordable, like it's mentioned. But there's more to it. As you can see in the slide, we got Sabre Splash, which is local. We have bottled RO water, bottled mineral water, and we have, as I mentioned, cistern water. There's a difference in all of them, as you can see here depicted. But the main point is RO water, reverse osmosis. It's basically a filtration system that takes everything out of the water, like we also do down at the Fort Bay, the desalination plant. It strips the water of everything. As we call it, zero water. There's absolutely nothing left in it. You can drink it, but it actually takes your stored minerals away from you. So it's actually to no benefit. It's actually harmful. And if you Google it, you'll find out it's not really safe for consumption either. We have imported bottled mineral water. We don't have any wells or springs or rivers that we have to our availability. So, like I said, we desalinate our seawater. We are located in the middle of the island, I would say. If you go down to the bottom, somewhere on the right, after or just before St. John's, you will see this building. That's where we're at. So our reverse osmosis water is pumped up the hill through different pipelines in and underground and alongside the wall. You might have seen them on your walking trails, these 2-inch black pipes along the wall. Those are ours. They transport the reverse osmosis water up the hill. It's still zero water, as we call it, and it gets stored by us in our own cistern, our tanks, and that's where our process starts. We have, number one, an active carbon filter. That's where the whole stage starts in the purification. It takes out any smells, any tastes, and the chlorine that's added. By law, we must add chlorine because we're using a pipeline that is exposed to the sunlight. So to avoid anything algae growing, we add bleach. So at the start of our whole system, we filter everything out, including the chlorine, any smells or tastes. It then goes through our RO filter because the water that is processed at the bay, it takes up to 1% of salt out of the water that's left in it then. So we take that 1% out. So after our reverse osmosis process, it's officially zero water, nothing left. The third spot is the ultraviolet light. It passes through that, and that basically kills any creepy crawlies that may be left in the water. Then we add our magnesium and calcium. That's where we remineralize our water, because according to the Dutch law, drinking water must contain minerals. Otherwise, RO water, it's not considered drinking water by law. Then we do step number 5, which is our ozonating. This is disinfection part of the water. We don't add bleach to our water. Like so many other products, they add bleach to make sure that there is a guarantee of no microbes left over. Ozonation, there's a picture of our ozonator. It's basically a machine, long story short, high voltage, add oxygen, you get a gas called ozone. It's a natural gas, and it makes the water uninhabitable for creepy crawlies. It stays active for about 3 days, then it dissipates. Then the final stage is the bottling part. So this is the first step, the active carbon filter. It contains charcoal, green charcoal as we call it, because it's from a sustainable product. It's made from coconut husks. So that's the first stage. That, like I said, takes out the smells, the weird tastes, and the bleach. This is our mini RO unit that takes out the last set of sediments, and it's preset, and it's a fine game adjusting everything, make sure it all works accordingly. This is our UV light. It looks big, but it's actually this size. This is the interesting part. Here we add our magnesium mix. This is the magnesium mix, and that's the calcium. So the water comes in on the left, it passes by, and it's automatically added, and it goes back into the storage tanks that are stored outside. Once we have enough water in our system, like I said, we start our ozonating machine, and this is a marvel. Many of the water bottling companies that are surrounded on the different islands, they use bleach or other chemicals to guarantee that there are no microbes in the water. So this is a very awesome part for us, that we are that far advanced. And then we have Big Bertha, as we call her, the final step, the bottling machine. The bottles are put in there. It passes through the front where we have a chemical called pyrene. Pyrene is just a dish liquid without bubbles. I keep wanting to put Dawn, but I'm told I'm not allowed to because it will be an awesome foam party. But the pyrene is, like I said, just a soap without bubbles, so it's no fun. It's boring. But it washes the bottles that we put into the system. We don't pre-wash unless it's necessary. We put the bottles in after usage. They get washed on this side. On the other side, they pass through the system. They get sanitized by a bleach mixture, so the bottles are therefore guaranteed clean. And then it gets filled in this part. And that beautiful weird hole is where the bottle comes out filled and capped, and it's ready for distribution. Before we reach to that part, we need to make sure that our water is safe. We have an independent laboratory, SLS, in St. Martin, that we have hired to do the testing for us. Each batch that we produce gets tested. Meaning, once we have the amount of water that we have in our storage tanks outside, that's ready for bottling, as we call it, once we have bottled that entire batch, we send our filled bottles, 2 or 4, to St. Martin by flight, and they test it, and they give us the results within 3 to 4 working days, depending if there's any kind of weather. It takes a little longer. But they let us know if it's good or if it's bad. Bad means not good for consumption, it gets dumped. Since we started 2.5 years ago, that's happened twice, the very first batch and the third batch, where we realized the tanks should not be out in the open sunlight because it encourages the growth of microbes. So we figured that out and we closed the tanks up, nice shed, no more problem. So we are proud to say that we can guarantee a safe product. As you can see, there are benefits to it. It's healthy water because we can guarantee it's safe. It contains the minerals that we need body-wise. Very important, less plastic. Just think about this for a second. The average person needs about 3 liters of water a day. That's 2 bottles, 1.5 liter. Quick math, 365 days a year. That's 730 bottles a year. Comes down to 60 boxes of 12 count bottles. That's basically what one person on Sable would drink, which ends up on the landfill. Yay, where we don't need it. So we encourage everyone, visitors and residents alike, please be smart about where we are at in the world. Please try to do as much as you can, reduce your carbon footprint, And of course, buy Save a Splash. And of course, if you do it in a modern way, you can purchase it at the government office, the main office, or you can purchase it online by emailing us the proof of payment, and we do free delivery. Awesome. Yeah. As you can see, water is definitely necessary in our system. It's a local green choice for a healthier you. We all need water, right? That's why we support See and Learn, because they help us to understand where we are. Any questions?
So this is a private for-profit industry that you have located on Saba? Or is it government institution?
It's a government institution that is trying to privatize down the line in the future, but for now, it's our own product.
Are you expanding to other islands in the Dutch Caribbean?
In the entire Caribbean, if it's up to me, but we're not there yet.
That's the next question.
We're not there yet. We need to make sure that in-house on island we're all set and we're all good, but we're getting there.
So locally, I could go across the street and buy your product.
Let me see. 6:14. The shop closes at 7. You could.
Good luck. I hope it expands.
Thank you. Thank you.
Thank you.
Thank you. Any more questions?
Did I miss this? The big plastic bottles, do you clean those and reuse them, right?
Yes, the 3-gallon and the 5-gallon, like we have that's on display. There's the small version, the 3-gallon, and the 5-gallon. We reuse them.
What's the lifespan of the bottles?
The lifespan, well, on paper they say you can reuse them up to 26 to 30 times, but it basically relates to how do the folks use them. I mean, they throw them, they mash them, how do they look? It's all about appearance.
Can you recycle them afterwards?
Yes, we can. We haven't reached that stage yet. We've got about 3,500 in rotation right now, and we've got some back that are no longer good for use, but the locals have found use for them. We turn them into planters, storage facilities for other things, or turning them into massive piggy banks.
So you don't have the smaller bottles, you only have the bigger.
Yes, that's correct. We only have the big ones. The main problem is, like on the first slide, where does the small bottle go? It's a common thing that everyone wants the easy access. Let's take the small bottle with us, but what we encourage is what this young lady is doing. Getting your own bottle and refilling.
Juliana's gives you a bottle.
Exactly. That's what we encourage, because it promotes a green island. And that's what we want. We want to reduce our carbon footprint. Yes, ma'am.
So I should not drink tap water?
The question is, where are you staying and what is your tap water? Because if you're staying at Juliana's, they would encourage you to drink bottled water. If you're not local, the water that you use that comes out of your tap mightn't be too safe for consumption. It's like playing Russian roulette. When you go to Mexico, would you drink the tap water?
So we've been staying at pretty much the same place since about 1996,
Mhm.
and I've always drank the tap water until you just told me I had to.
Well, like I said, it's a risk. They must have, well, must is a big word. They might have a filtration system in there that can filter sediment, but it's a risky section when you get to the microbes, because you can put a black filter in there, charcoal, an active charcoal filter that can filter out most of the microbes. So to make sure that you don't get any of those in your system, we would encourage you boil your water before you drink it.
Are you working with the local accommodation to have your product available to them? Once we check in, here's your product on the countertop.
Yes, several of the major hotels that we have here are working with us, and we provide that.
So you just go to that, and
Yes.
that's your drinking water.
Yes?
We recognize that local.
Yes.
Yeah, that's it.
Awesome. Any more questions?
Do you have the data to know that would actually reduce the import of the plastic bottles?
That is something we are actively working on. I hope by the next version of See and Learn 21 next year, we would have more info that we can add to that, because I just mentioned 730 1.5 liter bottles we are using, but to the average person, no one knows what volume, what size that is. So we're working on an active program. We've just started it to get as much information as possible to inform the public as to what is a carbon footprint that we have.
And another question, you said that you have to send the sample to St. Martin for the water whenever you have a drinking batch.
Yes.
Is there a way for you to actually do it here, or would that really require like a really big setup? Because we have the lab in the water, is it possible to do that? Or?
It is possible, but because we need to guarantee that we have an independent company that's non-biased, so to say, according to the law, we need to go elsewhere. And for us, the closest that is elsewhere is St. Martin.
I'm sorry, just one other question. Is there a way for me to test my water at home?
Yes, you could make use of the same facility, St. Martin Laboratory Services, but that's also part of a program that we want to start, that we can do some research locally as to what level and what guarantees can we find or produce with our local cistern water that we spoke of. What levels are they at? Are they safe? Are they not safe? Are they contaminated? Yes or no? It's something we've started.
Bring you the water and then you guys send it to St. Martin to get it checked. That'd be awesome.
Yes, yes, it is going to happen. We're working on that.
Are you getting any help from the Dutch government? The local government?
The local government is the forerunner, and the Dutch government is supporting everything that we're doing. So yes, we are getting the help that we need. Yes. Any more? No? Thank you.
Let's hear it for Oscar. He's a natural speaker. And a thank you to the Saba government, the Dutch government, because since 2010, they really have supported all of these things that make living here safer, better in many ways. So I hope everybody thought that was interesting. Cool, thank you. And especially if you don't even live here, it was interesting. So here we go. Oops, I'm going the wrong way. Sorry. No. Okay, sorry. Okay, so here we go. Tonight's keynote speaker and what you've been waiting for since you left Toronto, Canada. Here we are. Tonight's topic is a term you may be unfamiliar with. Does anyone know what an octocoral is? Well, that word, that prefix of octo might give it away, but you will be experts on this after tonight. So, Lindsay Huebner is a biological scientist in the coral program at the Florida Fish and Wildlife Research Institute in St. Petersburg, Florida. In her current position at FWRI, Lindsay conducts coral and octocoral population and health surveys within long-term reef monitoring programs at sites throughout the Florida Keys and the Dry Tortugas. As part of those programs, Lindsay trains her fellow colleagues and collaborators throughout Florida on coral and octocoral species and condition identification. Let's give a soft round of applause for Lindsay Huebner.
Sorry about that. All right. Okay. So first of all, thank you, Lynn, for the introduction, and thank you to the See and Learn Foundation for inviting me here to your beautiful island. It's nice to finally get here after being marooned on St. Martin for a few days. Also, thank you to Sea Saba for finally getting us here, Spyglass Villa for hosting my stay, and Shea Buba for providing this venue tonight for me to share a story of changes on Caribbean reefs with you. And many of you might be familiar with the changes in the stony coral populations and how they've been declining over time. But you might be less familiar with the octocoral populations, and those are probably what you refer to as the stony corals. Now, many members of my team, past and present, have generated many of the images and data that I'm going to share with you, but I'd particularly like to thank my colleagues Katie Cummings and Christina Malika for really helping me compile this presentation to share with you tonight. As Lynn mentioned, I come from the Fish and Wildlife Research Institute in St. Petersburg, Florida. You can see it here. This is the Innovation District of St. Petersburg. The first iteration of Marine Lab was on this site in 1955, and it was founded in response to a red tide event. But since that time, it has grown to be more than 20 field labs and 600 scientists distributed throughout the state of Florida. I am in the Coral Program, which was founded in the 1970s at FWRI. It was under a different name then, and it was really instrumental in understanding how things like declines in water quality and overfishing were contributing to poor coral health in Florida, and that included early studies on coral disease and coral bleaching. But since that time, we've really kind of expanded our focus, and we're kind of a benthic ecology group while still maintaining a main focus on corals. But we conduct studies on reef structure and erosion, genetic relationships, not just of corals, but of their microbiomes as it pertains to things like disease. And we also do kind of basic ecological research on describing habitats that are understudied, like those in the eastern Gulf of Mexico that you can see here. But our main focus and what takes most of our time are our reef monitoring projects, and those are in the Florida Reef Tract. So the Florida Reef Tract is the third largest barrier reef ecosystem in the world after the Great Barrier Reef and the Mesoamerican Reef. And the Reef Tract proper starts about in Biscayne Bay here and runs along the Arc of the Keys to just a little west of Key West. It's about 300 kilometers long. There's also associated reef ecosystems with the Florida Reef Tract, and those include the dry tortugas, which are further west from Key West, which is about here. And then also there's a series of ridge reef systems offshore from southeast Florida. We have a couple of monitoring projects in our program, but the one I'm going to focus on tonight is CRIMP, and that's the Coral Reef Evaluation and Monitoring Project. And this was founded in 1996 at the direction of the United States Environmental Protection Agency to understand how measures to improve water quality and protect areas of the Florida Keys may be impacting populations of seagrasses and corals. To assess the coral populations, we have a series of sites throughout the Keys that we monitor on an annual basis, and those are distributed across 3 broad habitat types in the Keys. So first we have sites on the reef crest, which is the sort of the barrier reef, and we have sites in the shallow part of that reef, and those are mainly your classic spur and groove reef systems. These are very shallow. They are the site of most of the historical shipwrecks in the Florida Keys, and as a result, many of them actually have lighthouses that are installed directly on the reef framework. And they have these high relief systems of bouldering corals and elkhorn corals. Paired with those, we have deep sites that are just a little further offshore that are actually geologically older for reef systems. So this is the shallow reef, this is the moving a little offshore to the deep. So they don't have as much relief as the shallows, but they have a slightly different ecosystem to them. And then finally, we have an array of patch reefs here in the diamonds, and these are mostly situated in what's called the mid-channel area between the islands of the Keys. There's a lot of sand, and then the fore reef is out here. There's scattered patch reefs throughout this channel, and they're quite variable from one another, but many of them have really high coral cover. We also survey sites out in the dry tortugas, and the dry tortugas actually have very, very little land area, but on one of those tiny little islands is actually this really neat 19th century fort called Fort Jefferson. It has like a moat and a moat wall, and there's corals growing along the moat wall, so if you've never been, I highly recommend checking it out. Even though there's not that much shallow land area, we have a couple of patch reefs out there that we survey, a couple near Fort Jefferson, and they were chosen for their populations of the branching corals, elkhorn corals, and staghorn corals. But most of our reefs in the dry tortugas are deeper, and they're pinnacle and bank reefs that you can see in the circles and hexagons. Pinnacles are kind of like deep patch reefs that you can see scattered amongst the sandy area here, and bank reefs are sites situated on areas of depth change. And these are the sites that are probably most similar to sites in Saba that we have in Florida. And they're characterized by very high relief of the bouldering corals. So what do we do at each one of these survey sites? We visit them annually, the same exact site, and on top of that, we survey actually the same area of the reef each time. And we do that by having these stainless steel stakes that are installed into the reef framework, and they're arranged in pairs, and this is sort of an example site map of one of our sites. So we get in, we find one of these stakes, we navigate around to the rest, and we connect the paired stakes to create our survey transects. And we connect the stakes with these survey transect tapes, and then once we make sure that's nice and taut, so it's replicated exactly the same way across the years, we then lower a chain that follows that transect tape, and that allows us to be able to precisely measure from the sort of imaginary line of the transect as we're moving up and down the bottom. We do a variety of surveys from this transect chain, including population surveys of corals and octocorals, which include counts of total colonies, and then also assessing their condition and which species are in the survey. And I'll talk a little bit about those survey types later. But for now, I'm going to focus on our image transect survey. And that's what you can see my colleague Tiffany demonstrating here. It's just moving down the chain and taking a series of abutting images along that transect. What we do with those is we throw them into a program called point count, which randomly smatters points onto each one of these images, and we go through and very tediously identify what each one of these points lands on. So for example, we have points on a couple different species of corals, sponge, bare rock, octocorals. And what we find is that this program, because this data set has been running since 1996 in the exact same way that we've been gathering these data, we have found it's been very effective at capturing the decline of stony corals in Florida. So this is the percent cover, so this is how many of those points are landing on live coral and across our images in each one of our sites. So starting in 1996, we had about 12 to 13% cover of stony corals in the Keys. But after sort of series of unfortunate events in the Keys, notably the 1997-98 El Nino, which is a severe bleaching event, we're now sitting at about 5% stony coral on reefs in the Keys. So for years, the prevailing theory has been that when stony corals decline, the reefs are just going to become coated in macroalgae. And that is certainly the case on some reefs, but it's not the case necessarily on all reefs. And this idea is called phase shift. So, as stony corals go down, it's going to shift in phase to macroalgae. And we haven't really seen that exact mirroring effect. So this is the percent cover of stony corals. This is the percent cover of macroalgae. It's not just one's down, one's up, and they reflect one another. Instead, there's a lot more going on to the dynamics of macroalgae, and it can go up in a lot of years and then down independent of the cover of stony corals. But our program was really the first to identify another player in this idea of phase shifts on coral reefs in the Caribbean, and that is the octocoral community, or what you know as soft corals. So that's the purple line here. And you can see that in some years it declines, like in that 1997-98 El Nino event, but it also bounces back, and it has kind of ups and downs. But nowadays they're doing much better than are the stony corals. And this what does this look like on coral reefs? So we actually have a couple of examples from our survey stakes. We take panoramic images so you can get an idea of what the reef landscape looks like. So this is one of our Upper Keys sites called Grecian Rocks. This is what it looked like in 1996 at the beginning of crimp. You have a massive star coral, I think, Orbicella annularis. I'm not so good with my common names. And then a nice big field of the elkhorn coral, Acropora palmata. But just a couple years ago, this is what that exact same part of the reef looks like on Grecian Rocks. Fortunately, the star coral is still alive and well, but all of the Acropora palmata are gone. You can see a couple of skeletons left, fragments of skeletons on the bottom, not really any macroalgae, and just some sea fans. Another example of that, this is a reef in the lower Florida Keys called Western Sambo Reef. Again, nice stands of the elkhorn coral, but we also had extensive fields of the fire coral, Millepora complanata, which makes these nice blades that created a lot of structure on reefs in Florida. But this is what that exact same area of Western Sambo Reef looks like now. All the elkhorn coral are gone, all the fire coral are gone, and instead we just have a few sea fans, some sea plumes, and a little bit of this encrusting zoanthid called Palithoa. And this is not just something that's happening in the Keys, where you sort of see these octocorals come in. Even in the dry Tortugas, where stony coral cover is relatively stable, we are seeing, and for whatever reason, macroalgae cover is always high, we are seeing kind of a trend of increase of the octocoral population. And it's also not just in Florida. There are unfortunately not a lot of folks who are studying the octocoral community, but some early efforts in the 1980s in Puerto Rico have shown how after changes of a reef, for example, removal of sediment has resulted in an increase of the octocoral community. But also there's another long-term monitoring project in St. John that has shown that as stony corals have declined, they're getting these forests of octocorals move in their absence. So the question is, why octocorals? Like, what about them is enabling them to do relatively well on modern day Caribbean reefs when stony corals are not doing so well? So we're going to kind of compare and contrast their biology a little bit to get a better idea of why this is. So octocorals and stony corals are actually closely related in the phylum Cnidaria, which is just about everything that will sting you in the ocean that has a round symmetry to it, or radial symmetry. They're both together in the class Anthozoa, and that means that they live in colonial groups. So single polyps, like a jellyfish here, instead they're stuck to the bottom and they form a colony of like multiples of them. The stony corals and their flashier cousins like the sea anemones and the corallomorpharians are in the group Hexacoralia, which means that their radial symmetry is usually in a six-fold pattern. Some of them don't play nice. Whereas the octocorals, as I'm sure you have guessed, have an eight-fold symmetry to their polyp, and they're always that way. So anytime you see a cnidarian polyp on the bottom with 8 tentacles, it is an octocoral. And the octocorals you may usually know as the soft corals, but that's actually a term that's reserved for a specific type of octocoral, and that's this kind here that dominate shallow reefs in the Indo-Pacific. These are the sort of true soft corals scientifically. But most of what we have in shallow reefs in the Caribbean are these Gorgonian octocorals. Now, what makes an octocoral a Gorgonian? Well, first, it has an internal axis, which is a structural support that gives it its shape, that's made from the protein gorgonin. And you can see that axis here and here, and you're really only going to see it in water on colonies that have suffered some sort of predation or damage. So both of these colonies have been predated. So these are the flamingo-tongue snails that have moved along, slurped off the tissue, and left the axis behind. This is actually evidence of fireworm predation, taking off the tissue and leaving the axis. And they do the same thing to branching stony corals, leave the skeletons behind. But in addition to this axis, Gorgonians use structures called sclerites, which for the most part you're only going to see on damaged colonies in water. Those are these little grains of rice right here. They're very small. And you might see them on like the tips of branches or on very small colonies, and they kind of like arrange themselves into this pattern, and that's what helps sort of protect the tissues and give the colony structure. These sclerites are made from calcium carbonate, which is the same thing that stony corals use to build their skeletons. So here's some comparison images of stony coral skeletons and their sort of dentition, and then octocoral sclerites. And in the same way that stony coral sclerites are what you use to identify them to species, octocoral sclerites are species specific. But you can use the skeletons of stony corals in water to identify them to species. So these were somewhat similar appearing stony corals here, but if you look at their skeletal traits a little more closely, you can see that they're two different species. Octocorals, because their sclerites are internal and very small, you can't rely on them to identify them to species in water. So instead, you have to use a variety of characteristics, the first being its general growth form. Is it a plume or pinnate, like that colony in the left here? Is it a fan? Is it loosely branched? Are the branches very bushy? Or is the branching in a single plane, which is a candelabrum pattern? These can only get you so far, though, because these can vary within species based on not just habitat, but region. So somewhere, a reef that's very protected, a colony might have very tall branches that are very bushy because it's not subject to very much wave action, but that same species in an area with high wave action might have short branches that are very loosely arranged. So you additionally have to look at characteristics like the angle that these branches are coming off to identify these two very similar species apart from one another. You have to use texture. Is it slimy? How slimy is it? Because some of them are slimier than others. Smooth or sandpapery. And then also some other finer scale characteristics like the calyx, which is this tube that the individual polyps live in. It's very long on this species here, Unicea succinea. And then aperture, which is the opening into which the polyp retracts, and you can see all those here. And so, like for example, how wide are these apertures? How closely spaced are they to one another? And if you can look at those characteristics, you can see there's actually two different species of octocorals in this picture. This Pseudoplexora porosa has very large apertures that are densely packed, compared to this colony here, which could actually be one of two species, smaller apertures further spaced apart. So hopefully, those of you who are on the field project tomorrow or who are interested in approaching this challenge of identifying octocorals to species are looking forward to this, because this is actually one of the major hurdles on reef research to including octocorals in survey programs, is how difficult they are to tell to species. Now, all of these colonies of Gorgonian octocorals use a holdfast, which is the structure that attaches them to the reef. And it can be quite large in areas where the octocoral might be experiencing a lot of water motion, or just be a very small attachment point. If the octocoral does break and fall to the bottom, it can reform a holdfast and start branching upward, as long as it doesn't get buried and is able to stay in one spot for a little while. And this is the same asexual reproductive strategy that the branching stony corals use to create new colonies of the same genotype. Stonies and octos are also similar to one another in how they sexually reproduce. So colonies of both groups are either broadcast spawners or brooders. A broadcast spawner releases sperm and eggs into the water where they're fertilized. They become a larva and they settle into the bottom in a process called recruitment. A brooder, only male colonies release sperm. Female colonies intake that. Fertilization is internal, and then she releases competent larvae that settle into a recruit. So we thought in our program, if these two groups, stony corals and octocorals, aren't very different in how they reproduce, perhaps one of the reasons we're seeing octocoral populations increase is the octocorals are just more successful at it in modern day reefs. So to study that, we used something called recruitment tiles, which are basically just tiles you would use for flooring in your house or in your bathroom. And we deployed these to the reefs, and it's just a set area that we can study and leave on the reef for a set amount of time. We left ours in for a year, and then we pulled them out and scanned these tiles for recruits, or just the very newly settled babies of octocorals and stony corals, and you can see those here. This is an octocoral recruit. For frame of reference, this is the tip of a mechanical pencil. So that's how tiny these little guys are. That's a stony coral recruit. And what we found is that actually the stony corals are recruiting better than are the octocorals, and that was unexpected. So in these bars over here, the stony corals are orange, octocorals are purple. They recruited about the same in 2 out of 3 years of our study, but in 2018 we actually captured a boom recruitment event of the massive starlet coral, Siderastria cinerea, which just one species of stony coral far outpaced anything we found from the octocorals. So then we thought, all right, so the octocorals aren't recruiting better, perhaps these recruits are surviving better, and that's why their populations are doing better. So to do that, we looked at the juvenile life stage, which is just post-recruitment up until the colonies are about 4 centimeters in size. And so at our crimp sites that we deployed the settlement tiles at, we did juvenile surveys using these quadrats that were in the exact same location every year. So we put these down, and then we would just stare at the bottom, looking for very small colonies of octocorals and stony corals. And again, surprisingly, we found more stony coral juveniles every year than octocoral juveniles. But when we looked a little more closely, we had the same composition of that community of stony coral juveniles across our 3 years of study. And that's actually because we were surveying the same stony coral juveniles each of the 3 years. So this community wasn't turning over on an annual basis. So these are some images of juvenile stony corals. This is the great star coral, Montistrea cavernosa. They're often fluorescent when they're babies. It's really cute. This is a juvenile boulder brain coral before it starts to form a brain pattern. So these colonies are growing very, very slowly, and this supports some research that's been found in the Virgin Islands and St. John, that the growth rates of juvenile stony corals is only on about like 0.03 centimeters a year. So very, very slow. So even though these juvenile stony corals are outnumbering juvenile octocorals on an annual basis, it's just the same ones across years. But when we looked at that community composition of the octocorals, it was new members each year. So this is where we really see the octocorals, how they're starting to do better than the stony corals. So this graph is just showing you an array of, these are codes for octocoral species. But what you're really looking at is the growth rate, that's linear extension. And so these octocorals are growing about 3 to 6 centimeters a year. And so that's about 100 times as fast as the stony corals are as juveniles, and the juvenile octocorals grow even faster than the adults do. So practically, what this means when you're a baby stony or octo on a reef, this octocoral juvenile here, this is the slimy sea plume, Antilogorgia americana. They settle, even though there's not as many of them each year, they settle, they're able to rapidly grow upright and escape this competitive environment on the benthos. So there's a lot of macroalgae here that they're basically not competing with because they have this really small attachment point and upright growth. This juvenile stony coral, on the other hand, it's growing very slowly. It's staying this size for years on end. It's interacting with all this macroalgae, which has chemicals in it that makes it's not good for the stony coral. It's also being subject, by being small for so long, to incidental predation or getting buried by sediment. So the odds that this juvenile stony coral colony are going to die are just much higher than are the odds that this octocoral baby will die. So as I've kind of hinted at, modern-day Caribbean reefs are characterized by disturbances, which in ecology is really anything that just kind of upsets the ecosystem. And these include things like repeated warm water events, which result in coral bleaching. Also disease outbreaks, not just on the corals themselves, but on the diadema urchins, which are very important for grazing macroalgae. I believe you had a presentation about that. And then also increased incidence and severity of hurricanes. And so we can use some of these specific disturbance events to look at their effect on the octocoral population. And octocorals are not immune to these disturbances, as you remember from our percent cover graph. This is an image actually from this year. This has been the warmest year on record, and it's been very detrimental to all members of the reefs in Florida and elsewhere. So this is a heat stress effect that happens to octocorals, where their tissue just starts to fall off when they get stressed out. So this is my colleague, Katie Cummings, just kind of shaking a stressed colony and its tissue just flies off. And octocorals are also subject to diseases, including some of the same diseases that stony corals can get, like red band disease. But even though they can be upset by these disturbances, they use those characteristics to bounce back. So we can see that after Hurricane Irma, which struck the Florida Keys in right about here in the lower Florida Keys in 2017. And if you remember, I mentioned that we do population surveys on our chain transects, and those include counts and measures of stony coral and octocoral species. So if we look at the total count of octocoral colonies at these two reef sites here called Alligator and Tennessee, which were on the worst side of the storm to be on, the populations of octocorals were stable at these reef sites up until the hurricane hit, and then they were decimated. So they're just ripped out of the reef or broken, but they start bouncing back a year later, and there's now actually more of them than there used to be before the hurricane, probably because there's more space available because other things were killed as well in the hurricane. We survey the heights of specific species of octocorals, and looking at the heights of the slimy sea plume, which is that little juvenile I showed you earlier. The average height of the colonies on these reefs was also stable up until the hurricane, until they were all broken or ripped off the reef. And it takes, a couple years before they start growing up in height again. Another example, not just of recovery, but kind of moving into a new area, is the case of Admiral Patch Reef. This is one of our patch reefs in the upper Florida Keys, and it actually had some of the best populations of stony corals of any of our survey sites. So this is Admiral in 2007. You can see this nice big field of that star coral, Orbicella annularis. But this site suffered the effects of a actually extreme cold water event in the winter of 2010, and all, or almost all, of the stony coral tissue was killed. And you can see in its place come in the octocoral community. And so this actually used to be a very large colony of the Boulder brain coral, Copophilia natans. And so you can still see that brain pattern on the rock. But what you're looking at is just this sort of massive increase of the octocoral population following the loss of the stony corals. And there really weren't that many octocorals there because pretty much the entire reef site was stony corals. And then similarly, you're seeing that not just are there more of them, but they're also getting bigger. And so what this looks like, coming back to our pans, that's Admiral again in 2007. This is Admiral post-cold water event. All those star corals are dead. You're starting to see some sea plumes and fans come in. And this is Admiral nowadays. It's a full-on forest of octocorals. So what does this mean for reefs in the Caribbean to go from, this nice, hard stony coral structure to being an octocoral forest? And it is, of course, definitely bad that we have lost so much of our stony corals. But we actually don't know exactly what it means for our reefs to be octocoral forests now. And that's because so few people are studying them. I mean, most of the focus is on stony corals, and that's rightly so. But I think it's important that we have more focus on some of these other members of our reefs to really understand, what their dynamics are. But the few studies that have been done on this octocoral forest indicates that it's probably not that bad for our reefs to be in this state, at least relative to a reef being covered in macroalgae. And part of the reason for that is because these aren't new species. So I haven't talked about any invasive species coming in to our reefs. These are all native species. They were all on the reefs to begin with. So what really this is not an invasion. It's just kind of an expansion of the habitat use of octocorals into areas that used to be dominated by stony corals. And the good thing about these being native species is that our native members of the reef recognize them as habitat. So for example, in these octocoral forests, I've seen large predatory fishes hunt and lurk amongst the forest. These smaller fishes will use them as habitat and structure. For example, this damselfish is tending to a couple clutches of eggs here, sort of aerating them. You can see these two different clutches here, and these white dots and the sort of black fuzzy dots over there. And then also cleaner gobies, which as you may know, will use large coral heads as the centers of their cleaning stations. In areas absent large coral heads can use sea fans in the wide planar area of the sea fan to locate their cleaning station. And so it seems that the octocoral forest is actually a really good placeholder habitat for our coral reefs to be in the absence of stony corals, and until such time as stony coral populations can be sort of rehabilitated. And they may actually be good or even better for stony corals because by providing so much habitat to our native reef members and providing habitat particularly to grazers of macroalgae, the octocoral forest can actually result in bare substrate that is free of macroalgae by the action of the grazers that are living inside of it. And that bare substrate is available to stony coral recruits. So it may enhance the recruitment of stony corals. But kind of moving beyond octocorals as just sort of a backup stony coral habitat, I'd like to suggest that they are very important members of the reef because there are many organisms that identify with them directly that aren't just using them in the absence of stony corals. And so they're an important contributor to the biodiversity of our reef systems in the Caribbean. So for the macro photographers among you, you should be paying a lot of attention to octocorals because they have a lot of really interesting associations with small shrimps. And so there's small shrimps in each one of these photos here. Many of these are not described, actually, and they're very specific to the type of octocoral that they will associate with. Here's another little shrimp here. There are also mollusks that specifically associate with octocorals, like the flamingo-tongued snail, which you saw earlier, which will only eat octocorals. There's also different types of oysters that like to attach themselves to octocorals. And then finally, some different types of sea stars, like basket stars, are often found primarily in octocorals. And then here, you can see this sea fan is serving as the juvenile habitat for brittle stars that have just hatched. So all of these little orange lines are hundreds of brittle stars using that sea fan. But finally, I'd sort of like to humbly suggest that the octocorals themselves are beautiful, whether that's as their own forest with a mixed diversity of octocorals or mixed in with your stony corals. They are important members of our Caribbean reef communities, and it's only by increased attention from not just the scientific community, but also sort of recreational dive community that we'll get a better idea of understanding the different threats to them, but also how they're doing and what types of services they're providing to reefs in the Caribbean. And with that, I'll take any questions.
So it seems to be that you're a little bit biased towards the soft corals, the sea fans, and everything like that. But is this an evolutionary shift? Because the hard corals are going to provide the shelter for the native habitat. Do you find a decline in certain species? I've seen flamingo tongue as species like that. But do you see a decline on native fish that rely on the shelter of a hard coral?
Yeah, so the question is, do we see a decline of fish in the absence of stony corals, certain species of fish? And the answer is not necessarily quite yet, and that's because the decline of stony corals is so new that even though their tissue is dead, a lot of their skeletal structure is still on the reef. But over time, as that structural framework starts to erode away, you will start to see fewer fish because there's less structural habitat available for them. And I'm answering this not as a fish biologist. So
They need that shelter.
They do, right, yep. So the good thing is because the octocorals are providing some vertical structure and habitat, that the fish can use that. But yes, it's definitely not the same type of framework that the stony corals can provide.
But there will be a shift back towards the harder corals, stony corals, evolutionary speaking.
I don't know about evolutionary. I'm not sure I understand your question about a shift back evolutionary.
It seems to me that there's a shift, a decline of harder corals, shifting over to the softer corals, the sea fans. I see a big difference between the original photograph and the more recent photographs. I'm just wondering if that's evolutionary, or is it our impact on the oceans that are creating that?
It's primarily our impact. So the reasons that we've lost so many of the stony corals is just, I mean, there's main events like the bleaching events or disease outbreaks, but it's kind of death by 1,000 cuts. You know, it sort of depends on, you know, where you are, but it's bad water quality, it's overfishing, it's removal of predators, you know.
Populations on sea coasts, pollution going into the ocean?
Yep, that can impact coral because that can increase coral disease. It can, by putting too many nutrients into the system, that can proliferate algae blooms, which can kill stony corals. And so, really, it's a lot of these disturbances that are primarily human caused that's causing the decline of stony corals. That's then allowing the octocorals to come in and take that space.
So are there places, being in Florida, being part of the U.S. Institutions, are you working towards addressing certain things that would change that?
There have been a lot of measures to improve water quality, for sure. An example of that is the removal of septic tanks in the Florida Keys. A lot of people used to use septic tanks, and those would seep out into the reef, but that's now all been addressed and gone. Increased protection areas for fishes that are, you know, that will graze the macroalgae. So there's a lot of areas where you can't fish throughout Florida, and that's to increase fish populations. But it's kind of hard to have measures to increase coral populations directly because a lot of the things that are impacting them, there's things that are impacting them on the local scale, but there's also so many things that are impacting them on a global scale that aren't really tied to regional management actions. You're welcome. Yes.
What depth are you working at?
She asked what depth we're working at, and some of our survey sites are very shallow at about 5 feet, and then we go down to our deepest site is about 80 feet.
Okay, so you've noticed the same trend with the 5 feet reef percentage?
The types of octocorals shift based on depth, but yes, we do see that same trend. It's kind of less. In the shallower habitats, it's more exaggerated, so a lot of the images I showed you are from our shallower habitats where the sea fans are more common, so it's just more obvious because the fans just take up so much visual space. But even in the deeper habitats, like out in the dry tortugas, on the pinnacles and banks out there, there's not as many sea fans, but even the sort of thin plumes are increasing in number as well. Yes?
With your sampling sites, have you been able to stratify between, say, a high octocoral bloomer and a low octocoral bloomer? How much variation would you say there is? And have you seen any impacts on other metrics, say your algae or fish biodiversity?
So the question is, within our study sites, do some have a lot of octocorals, like a large octocoral population coming in, and do some not? Yes, actually, some of our sites, for whatever reasons, haven't had a lot of octocorals increase, and then some, like that site Admiral, have just had them totally explode. What might be causing that? Some of it's sort of recruitment and larval dynamics based on water, how the water moves and how those larvae of the stony corals and octocorals move around in the water before they settle. Some of it is actually once a little bit of octocorals move in, they can actually enhance their own populations by creating this forest actually modulates the flow of water, and they can enhance their own recruitment by when they release those larvae, they then settle down right next to them because they're sort of stuck in the rest of the forest, and that's part of what causes that explosion. I'm sorry, I don't remember the rest of your question, if there was the rest of the question.
Yeah, I was just wondering if you had seeing if those high bloomers have any other impacts on their other metrics, say algae or biodiversity.
Yeah, the algae. There isn't a tight relationship between the algae and the octocoral community. Yeah, the octocoral community, I would say, is a little more closely related to the decline of the stony coral community. Yes?
You briefly touched on the fact that you weren't going to talk much about invasive species, but have things like lionfish, Florida's been plagued with lionfish and other areas, would they have had an impact on this as well, like other invasive species? And then what about invasive species in either octocorals?
So I don't think lionfish would directly play into the dynamics. Sorry, the question was, do invasive species have any sort of impact on this on these phase shift dynamics that we've been looking at. I mean, lionfish are voracious predators, and they can definitely decline populations of grazers, which are, you know, important for removing macroalgae from reefs. But I wouldn't say that they're a direct influence on the increase of octocoral populations. But I will say that even though this entire presentation was about native octocorals, there is now actually an invasive octocoral that's been found in the Caribbean. It comes from the Indo-Pacific and has very recently been noticed. It was first seen off the coast of Venezuela and now was locally a problem there because it's an encrusting octocoral that covers the entire substrate basically and just takes over everything. That prevents, yeah, native octocorals, stony corals, algae, everything from using that area. And it's now just this year been seen in Cuba. So we're witnessing probably the increase of an increased spread of an invasive octocoral. And you can identify it because it has a pulsing action to its polyps. And that's how you can differentiate it from, we have a couple of species of native encrusting octocorals. They don't pulse their polyps. So if you see an encrusting octocoral and the polyps aren't out or they're out and they're just waving around, it's native. But if you see a pulsing action across the colony, that's the invasive octocoral. If you see that anywhere in the Caribbean, you should definitely report it to the local management, natural resource management authorities. It's called, I don't know if it has I think it's called the pulsing octocoral. It's called eunomia. They're very popular in the aquarium hobby industry, and that's probably because that pulsing action is beautiful. So I think that's probably where it came from. Probably not from boats. They don't know for sure, but they think because of its popularity in the aquarium industry that this, the original invasion probably was not from a boat bringing it over. The question was it from, did it come to the Caribbean from a boat? Probably not the original invasion, but it might now be being transported within the Caribbean via boats.
Is there any large-scale survey in the Pacific? How many corals?
There are other groups that do large-scale surveys of coral reefs in the Pacific. Yeah, the United States government has some in our territories out there. The Australians have a lot of large-scale reef monitoring projects in the Great Barrier Reef. I'm sure there's numerous others. I'm a little less aware of the types of groups that work out there since I'm very Caribbean and Florida focused. Any other questions? Oh, yes.
Are you finding any new octocorals growing with resistance traits, like an evolutionary thing?
I wouldn't say, so the question is, are we seeing new, or octocorals have, or some like types of octocorals or colonies of octocorals that are resistant to things like bleaching or disease? And the answer is that we don't really know, and that's because historically there hasn't been enough studies on the octocoral communities to understand their prior susceptibility to disturbance events to now compare our current data to.
More data, okay.
More data. Everybody become an octocoral scientist.
I finished grade 12.
Excellent. You're hired.
You had mentioned there might be some stony coral that are still alive and reproducing among or near the octocorals. So if a larva lands and able to get a little foothold, do the octocorals kind of just by being taller protect those stony corals because they're small and grow so slowly?
So the question is, oh, I'm sorry, were you done?
Like some trees, protect the baby, the young trees.
So the question is, if a baby stony coral settles near octocorals, can the octocoral protect it in the way that like sort of a forest will protect smaller organisms within it? And the answer is yes and no. Again, more data. The octocorals can have some very potent chemicals in them that if they were directly next to one another, they would spatially compete. But oftentimes when I've seen that spatial competition where they start growing against one another, the stony coral will often win when it's healthy. But if it's not very healthy, which a lot of our stony corals now aren't very healthy, the sort of effect of those chemicals from the octocorals can affect its health. But there's also a positive effect in that by creating that canopy, they can actually shade the organisms underneath that canopy, and that can reduce like light and heat stress on stony corals. And so there's a lot of researchers that use just shades to reduce how bleached stony corals get, because it's that combination of heat and light that can really bleach stony corals. And so stony corals living under an octocoral canopy are getting a dappled light as opposed to direct sunlight, and so there's potentially less stress on them from the sun. Mm-hmm. Yes.
So, have there been studies looking at distance from one of these octocoral forests? Like you go a certain distance away, is there a distance effect on those different processes, right? So, being a refuge for grazers that might promote recruitment of hard corals, also being potentially a mechanism of reducing stress on those hard corals, versus being a competitor for space in those areas. Have you looked into how distance from those areas might influence those patterns?
So the question is, have there been studies, or have we looked at how the distance from an octocoral forest influences that grazing pattern of the fish and other grazers that live within the octocoral forest? Our program has not directly looked at that. The only other program that has is that long-term project in St. John, and their study on that was very recent, so they've just started to look into that effect. And they are finding that within and very near to the octocoral forest, you get the macroalgae graze down, but the further away you get from the forest, the more macroalgae there is. That was sort of the initial study, and my impression is that there's sort of going to be more follow-on studies to the larger effect of that.
And then on top of that, do you expect to see like increased octocoral recruitment near to those forests versus further away?
Yeah, that is definitely known that within an octocoral forest, they enhance their own recruitment by modulating that water flow. So when they get really dense, there's sort of not that much water current moving amongst the forest. They kind of shunt the water above their forest, and that not only increases their ability to reproduce within the forest, because all of their sort of sperm and eggs and larvae are sort of stuck within the forest, and they just kind of settle amongst themselves. But they can also increase their feeding within the forest by sort of modulating that water. They're increasing how much plankton is captured by the forest. Any questions?
Thank you, Lindsay. That was fantastic and a little bit depressing, but also some light into the positive. And I just want to say that I hope all of you as divers have takeaways from this, and non-divers, by understanding that everyone here can be an advocate of talking to friends and family and understanding that these threats to the world are real, and trying to dispel the non-believers and what it impacts, not just for you as a scuba diver, but what it does to our planet. So thank you, everybody. Before you run away, there's a lot of space for her octocoral dive tomorrow afternoon, so we hope we can get some more people to join that to better understand what's going on under there. And before you exit, because I know you're hungry and ready for dinner, you would help us a lot if you just take your chair and look for Emily in the orange dress, and she'll direct you on where to put it, and that'll help us break down quickly and help Adam get home at a decent time of night. Thank you, everybody. And we hope to see you tomorrow. Let us know. We need to know how many people are going to Queens that need a taxi so that we can arrange enough taxis. So Tammy's in charge of that. Mañana.